Okay, ready? 1, 2, 3.
People often ask, why would Honda set out to build an environmentally friendly, energy-efficient home? The answer is pretty simple. Honda is passionate about developing technology that solves our most pressing environmental challenges, and that passion extends beyond cars. What we're trying to demonstrate here is a vision for zero-carbon living and personal mobility.
Together, our homes and our cars produce about 44% of the greenhouse gas emissions contributing to climate change. What we're doing here is developing a technology pathway to meet California's goal of having zero net energy homes. But we're also trying to exceed that by including transportation in the solution.
Honda Smart Home is a zero net energy building. This means that our home generates, on average, more electricity from on-site renewable energy than it receives from the local electric utility. Our home is powered by a 9.5 kilowatt solar photovoltaic system. We're generating enough renewable energy to power not only our home, but also a fit EV electric vehicle. Honda envisions a zero-carbon future with electric vehicles powered by renewable energy. We're demonstrating a pathway for the full integration of electric vehicles into a home. Our home comes equipped with the fit EV battery electric vehicle. The fit EV has been modified to accept power directly from the home solar panels or from the stationary battery. Most solar PV systems convert their power to alternating current, or AC, the standard current in most homes. But electric vehicle batteries use direct current, or DC. Converting AC to DC results in a loss of energy. The Honda Smart Home uses DC power directly to charge the fit EV. With sunshine as its fuel source, the fit EV is transformed into a 100% zero emissions vehicle. Producing renewable energy is the first step in making our smart home sustainable. But what really differentiates our smart home from others is the energy management system. This system monitors and controls all of the home's loads, the fit EV, and the battery energy storage system. It actively manages energy use and communicates with the homeowner and the electric utility provider. For example, on a hot summer day when electricity demand is high, the energy management system can automatically reduce the home's energy demand and can even supply power back to the grid. Solar power and electric vehicles have the potential to solve serious societal problems, but they also present new challenges that we're addressing with this project. Both can cause disruptions to the electric grid by creating sudden and large changes in the demand for electricity. By continually monitoring the home's energy needs and communicating with the grid, the energy management system lets us balance our energy loads to help create a more stable electric grid.
That's 20 to the surface.
Managing energy loads is important, but reducing the home's demand for energy is even more important. In a typical home, heating and air conditioning systems consume significant amounts of energy. We're working with UC Davis researchers to develop several technologies aimed at reducing our home's heating and cooling needs. Below our yard, we dug 20-foot deep boreholes that allow a geothermal heat pump to recover heat from the earth and from the home's wastewater. And we've installed a radiant heating and cooling system in the floor and ceiling that has the potential to be more efficient than forced air heating. Building a sustainable house requires more than solar panels on the roof and energy-efficient systems. So the second goal of the Honda Smart Home is to demonstrate some important concepts in the design, building materials, and construction of a sustainable home. Concrete can be the single largest source of CO2 emissions from construction of a home. The large footprint is the result of the emissions from the production of cement, the glue that keeps concrete together. We've added a naturally occurring substance called pozzolan to our concrete, which will replace half of the cement. And we're using a technique called post-tensioning to compress and strengthen the concrete, allowing us to use less material. The Honda Smart Home uses a concept called passive design to maximize the home's energy efficiency. Basically, this means that we take into account the local weather conditions, the sun, and then carefully design the outer layer, or envelope. For example, our south-facing windows are optimized for heating and cooling, while the north-facing windows are positioned to maximize natural light and ventilation. This will keep the home naturally cool in the summer and warm in the winter. Finally, sustainability is more than just green features. It's also about health. Throughout our home, we've avoided the use of materials that emit volatile organic compounds and contribute to indoor air pollution. Expanding our focus on health, we've partnered with researchers from UC Davis's California Lighting Technology Center to explore new circadian rhythm color control lighting techniques to improve the quality of life for the occupant. Mimicking the natural shifts in daylight that occur from morning to night, the lighting design allows occupants to select lighting scenes that complement their natural circadian rhythms and support nighttime vision. These LED lights are also highly energy efficient.
In the end, you're either part of the problem or part of the solution, and Honda wants to be part of the solution.
Our hope is that the Honda Smart Home will help start conversations about energy and the environment and accelerate our efforts to develop technologies and policies that will help us build a more sustainable society.